All right, scholars. We're going to pick up with part 2 of our polynomial division explorations. In this activity, we're going to be focusing on the technique of long division to find the quotient of two polynomials so I can compare contrast diagrams and long division as ways of representing division. I'll know I've got it when I can use long division to divide polynomials. So in the last lesson, we employed the area model in the reverse direction in order to take polynomials of degree 4 and 3 and rewrite them in factored form. Well, I know it's been quite some time. I would like for you to make your best attempt at completing this polynomial division. Rather than use the sketch tool, you can use our math type button and type in, your thought process here and then move it accordingly. So that should streamline things. But let's see if we still remember what we were able to do 57 years ago. So in this scenario here, Diego used long division to figure out that the polynomial 6x squared minus 7x minus 5 can be rewritten in this manner: 2x plus 1 times 3x minus 5. Show what it would look like if he had used a diagram. So trying to create this bridge between these two ideas of the reverse area model and long division. Now here we are going to complete the long division ourselves. So as we can see, they have determined that their first term that they can multiply a known factor by is 2x squared. So if we multiply these two expressions together, we wind up with this expression. You might be wondering, well, where does this negative come from? Where does this positive come from? Remember, in long division, after we divide the initial polynomial or the initial number, we subtract, right, however many times we've divided into that particular number. And if this is something that is, really making you stress and, feel anxious, think back to doing long division with something like 50 divided by 6. Right, 6 goes into 50 8 times. That's for a total of 48. We would subtract the 50 and 48 and wind up with 2, which we would define to be our remainder. We're not talking about remainders yet. That's going to be our next activity. All right, so right, as we can see, 2x cubed minus 2x cubed will become a 0, and negative 7 plus 4 will leave us with a negative 3x squared plus x. And then I would ask myself once again, what times x, because that's the lead term of our factor, would create a negative 3x, oops, there we go, a negative 3x squared. Well, erase some of that. See you later. That would indeed be minus 3x, which would give me minus 3x squared plus 6x. However, remember, I would subtract this entire expression. And then subtracting the entire expression, I am ultimately going to alter the signs of these terms. Those two terms will create a 0. X minus 6x would yield a negative 5x plus 10. And from there, you should be able to figure out the final term of this particular expression. And now we are simply reverse engineering the process that we had done on slide 3. So you have the area model before you, and your job and responsibility to complete the long division accordingly. You have a polynomial, a of x, with 4 terms, and this known factor. I'm giving you both options to complete that division. and just ensure that your final polynomial is written as the product of linear factors. Couple instances to practice, and then work on our intuitive ability to factor quadratic expressions. By this point, we will have discussed what it means conceptually for an expression to be a factor, so you may not have to complete any type of division since we have factored form readily available to us. But if not, we'll talk about that in class, and that's where we'll pause this video.